Okay, so we're talking about the domain and range now of this problem here. So again, we're talking about the domain and range of the g of x function, not the parent. So the domain is your x values, and if you notice, this starting point is at 0, 0. So the smallest x value, or the largest x value actually is 0, and then it's going to the left, so your other x values are getting smaller. Also, if you look at the table, 0 is the largest x value, and then it's going to -1/2 and -2. If we keep going, it'll continue going in the negative direction farther and farther. So your domain would be x less than or equal to 0. Your range is your y values, and if you look at your graph G, again, it starts at 0, but its y values go up and down. So since the graph goes up, but it does not go down, it's going to be greater than or equal to 0. So your domain x is less than or equal to 0. Your range y is greater than or equal to 0. Okay, now moving on to number 24. In number 24, we have to find the inverse of each function, graph the given function and its inverse, and then determine if the inverse is a function. Okay, so we have, this is our starting value. So let's go ahead and graph what we have here. So this is a quadratic equation. You should recognize it because it has an x squared, and it's basically your parent function but going up 3. So if we were to graph that, or even just make a table of values, the parent would be y equals x squared, and your x values -2, -1, 0, 1, and 2. For the parent function, if we squared each of these values, we would get 4, 1, 0, 1, and 4. But because we're going up 3, we would have to add 3 to all of those values. And then so that the table for f of x would have the same x values, but your y values would be 3 units higher than each of the ones in the parent. So we would have 7, 4, 3, 4, and 7. So when if I graph that, -2, 7 is going to be right here, -1, 4, 0, 3, 1, 4, and 2, 7. So 0, 3 being our vertex. So a parabola is a function. If we were to do a vertical line test, we would only cross one point. However, its inverse, we can already tell that the inverse is not going to be it's not going to be a function, because if you were to do a horizontal line test, we would have it would cross more than one point. So if there's 2 points with the same y coordinate in the f of x function, then there will be 2 points with the same x coordinate in its inverse. So we can already tell that the inverse is not going to be a function. So I will put that note down here somewhere. The inverse is not a function. And again, when you graph the inverse, if you have the points here, your inverse, whether you call it f inverse of x or g of x, you could just simply switch or flip the x and y values. So instead of x being -1, 0, 1, and 2, your y values, or your output values, would be -2, -1, 0, 1, and 2. And then your input value, or your output values, are now going to be your input values. So now you can see for sure this is not going to be a function, because there's 2 points that have an x coordinate of 7, and 7 has more than one y value, and the 4 also has more than one y value. So again, the inverse, that proves the inverse is not a function. But if we graph it, 7, -2 would be right here, 4, -1, 3, 0, 4, +1, and oops, I graphed this point wrong. 7, -2, and 7, +2. So that would be our inverse function. And as I always like to show, the inverse, or the line of reflection, for all inverse functions is the line y equals x, or the line of reflection. Did I say line of, I think I said line of reflection. Yeah, line of reflection is the line y equals x. And if we looked at this graph, you can see that these are symmetrical, or they would be mirror images of each other across that line y equals x. All right, so we graphed the original equation, label it f. We graphed its inverse by just flipping the points, but we haven't done, and we've also stated whether or not it's a function, but what we have not done yet is found the inverse. So to find the inverse, I would take this equation and basically your f of x equals y. So if this is y, and then we flip the x and the y values and then solve for x, or solve for y, that will give us our inverse. So instead of y equals, I'm going to write x equals. And instead of x squared, I'm going to write y squared, and then plus 3. So I know I'm kind of running into this problem here. So now the goal is to get the y by itself. So in order to get y by itself, I have to subtract 3 now. And I will now get, so my new equation will be y minus, or x minus 3 equals y squared. Then I'm going to need to take the square root of both sides, and because it's an even root, there's a positive and a negative. And then in the final answer, you should not say y, instead you should say g of x equals positive or negative square root of x minus 3. So there we have it. That's our inverse of f of x. So this is the equation, this is the graph, and that's the graph of f of x. So have we done everything? Find the inverse of the function, graph the function and its inverse, determine if the inverse is a function. So yes, we already did that. All right, so now let's go to the next one. So in the next one, you have a cubed root. So your parent cubed root is y equals the cubed root of x, and we can take a negative number to a cubed root, so we're going to just use -1, 0, and 1. The cubed root of -1 is -1. The cubed root of 0 is 0. The cubed root of 1 is 1. But then we have this -4, which means that we're going to basically move all the y coordinates down 4. So if I'm going to graph g of x, the x coordinates stay the same, but my y coordinates all go down 4. So -1 minus 4 will give me -5, 0 minus 4 is -4, 1 minus 4 is -3. So when I graph those 3 points, -1, 5, oh, I'm sorry, -1, -5. Okay, so that's a little farther down there. And then 0, -4, and 1, -3. Keep in mind that it's going to be have that S curve in it. The 0, -4 is our center point, so it's going to kind of curve up and to the right, and then curve down and to the left. So that is our starting function, g of x. To graph the inverse, so since this one was g of x to begin with, I'm going to say g inverse of x. Or you could call it something else like f of x. But again, we're going to switch the x and y values. So instead of x being -1, 0, and 1, the y values are going to be -1, 0, and 1, and the x values are going to be -5, -4, and -3. Then when I graph those, I'm going to get -5, -1 right here, -4, 0, and -3, 1, which looks a lot like what we had here. So let's just hold off on graphing that for a second, because the inverse of a cubic function is not another cubic function. So I'm sorry, I just gave it away. It is going to be the inverse of a cubed root function is a cubic function. But let's see what it looks like before we start graphing it. So we got the 3 points. But let's go ahead and, again, switch our x and y. So instead of g of x equals, we're going to put x equals. Instead of the cubed root of x, change it to the cubed root of y minus 4. And then now we want to get the y by itself. So add 4, and we get x plus 4 equals the cubed root of y. To get rid of the cubed root, you have to take both sides to the third power. So that gets rid of that. Now you do not need to actually take the x plus 4 to the third power, like x plus 4 times x plus 4 times x plus 4. That is not necessary. So basically we have x plus 4 to the third power equals y, or better, g inverse of x equals x plus 4 to the third power. So that is your inverse function. It's a cubic function. And the x plus 4 tells us it's a horizontal translation to the left 4 units, which you can see horizontal translation to the left 4 is going to be our center point. But instead of the graph going to the right and left like the cubed root does, we do have an S-curve, but it's going to be going up and down. So that is our G inverse, and this is G. And again, if you were to draw on that line of reflection at y equals x, you would see that symmetry there between the inverse and the graph itself. Okay, so now we have to answer the question, is the inverse, determine if the inverse is a function. If you look at your table values, do any of the x values repeat? No. Okay, so that's a good start. If we were to do a vertical line test, I know this is very steep, but it really does not have any x values that are the same. It does continuously go off to the left little by little, and this one is going to continue to go to the right forever and ever. So none of these x values will ever actually be the same. So the inverse is a function. For the cubed root and the x to the third. All right, moving on to page 5. So on page 5, number 26, it says to write the composite function. So they're giving us g of x, or f of x, and they're giving us g of x, and they're asking us to write the composite function f of g of x, which means you're going to substitute the g of x function into the f function. So we're going to take what g of x equals, which is negative 2 square root of x, and you're going to substitute it into the f function. So this is what that's going to look like. So the 9 will stay the same, but instead of x squared, it's going to be negative 2 square root of x to the second power. So the 9 stayed the same. We replaced x with the negative 2 square root of x, and then we're going to square it. Now we want to simplify. So since you're squaring this negative 2 square root of x, the negative 2 squared is going to equal, no, it's not going to equal 2. It's going to equal 4. And then when you square the square root of x, you just get x. And then you have to multiply it times that 9, and you get 36x. So f of g of x is going to end up being a linear function, 36x. Kind of interesting. All right, the next one, for part B, instead of substituting the g function into the f function, we have to substitute the f function into the g function. So we're going to take that 9x squared and substitute it for x into the other function. So the negative 2 would stay the same in front, but instead of x in the parentheses, it's going to, or under the radical, it's going to be 9x squared under the radical. Well, it just so happens that both 9 and x squared are perfect squares, so we can simplify the square root of 9x squared. The square root of 9 would be 3, and the square root of x squared is x. So when you multiply that together, you get negative 6x, which is another linear function. But again, we want to write g of f of x equals, so it's got to be an equation or a function, not just negative 6x. So don't just give me negative 6x or positive 36x. tell me f of g of x equals, or g of f of x. Or you can use this notation with the f of g of x equals, or g of f of x equals. All right, so that's your composite functions. We also used composite functions to determine whether if the following functions are inverses of each other. So one of the rules that we learned is that I'll write this over here, if f of g of x equals x and g of f of x equals x, then f and g are inverse functions, or they're inverses of each other. So if I, again, use the composite function and I take the g of x function and substitute it into the f function, so f of g of x is what I'm doing right now, the negative 2/3 in front would stay the same, but replace that x, but the plus 2 at the end would stay the same. So the negative 2/3 and the plus 2 would stay the same, and then you substitute this in the equation for x. So now when you multiply that out, different color, the negative 2/3 times the negative 3/2 would give us a positive 1x. The negative 2/3 times the 3, sorry about the vacuum in the background, the negative 2/3 times the 3 would equal a negative 2, and then you'd have this plus 2, which would simplify to just 1x. So that does equal x. But then the other one has to also work. So if we were to take the f function and substitute it into the g function, this should also simplify to just x. So let's see. So this is g of f of x. So the negative 2/3, actually I don't think I'm going to have room here with this. Move it down a little bit. So the g of f of x, negative 3/2, you're going to replace this x now with the f function, negative 2/3 x plus 2, and then you've got that plus 3 at the end. So when you distribute, the negative 3/2 and the negative 2/3 become 1, which gives you then just x, and the negative 3/2 times the 2 would equal negative 3, and then you have that plus 3 there. So again, those cancel out, and you get just x. So using our rule here that if f of g of x equals x and g of f of x equals x, then f and g are inverse functions, we can then state they are inverse functions. So you've basically proven that they are inverse functions using composite functions. All right, so let's try it with the next one. So in the next one, we have a quadratic equation and a square root. So this may or may not be easy to put in the other equation. What you may want to do is just find the inverse function here instead of substituting one into the other. So you could substitute this in for x in the other equation, but it gets a little messy. So rather than substituting into the other equation, I'm just going to find the inverse of f of x and see if it equals g of x. So if I were to change this to y and switch my x and y, I would get x equals parentheses y plus 4 squared minus 5. And now the goal would be to get the y by itself. I keep using that pen and it's dead. It has no more ink in it. All right, so I want to get the y by itself now. So I would add 5. And these are not like terms, so just rewrite it as x plus 5 equals y plus 4 squared. Now to get rid of the square, you're going to have to square root both sides. And when you square root both sides, because it's an even root, you will have a plus or minus. Square root of x plus 5, and then equals, The square root and the square cancel out, and you get y plus 4. And then the last step to get the y by itself would be to subtract 4. But that 4 is not going to go under the radical. So this radical is going to be separate from that minus 4. So I would then get, so if I take all of this and rewrite it up here, I would get y equals plus or minus the square root of x plus 5 minus 4. So this would be the inverse function. Or if I said g of x equals plus or minus the square root of x plus 5 minus 4. So this is the inverse of f. And you can see here that the signs are flipped, so they are not inverses of each other. So g of x is not the inverse of f of x. Okay, so that's 28. We've got about 3 more to go. 29, the maximum hull speed. So we've got story problem here. We've got v, which represents the hull speed in knots of a boat, can be approximated by this equation here. And notice that's a script L, it's not a 1. And that script L is the length in feet of the boat's waterline. And it says find the inverse of the model. So when you are finding the inverse of an equation where your variables actually represent something, like in this story problem, do not switch the variables. Do not switch the variables. Just solve for L. Okay, so we're going to take this equation and we want to solve for L. So I'm going to rewrite it over here. V equals 1. All right, it seems there was a little bit of a glitch with numbers 29 and 30. So I have to go back and re-record this. So let me just kind of go through what I did here. So this is your equation, and you're finding the inverse of this equation. So you are not going to switch the variables, again, because your V and your L represent things that are significant, not just plain old X and Y. So basically we took this equation and I rewrote it over here, and then I want to solve for L. So I'm going to divide both sides by 1.34. Then the V over 1.34 was here, and then I brought down the square root of L. And then to get rid of the square root, I square both sides. And then my new equation then is just going to be L equals V over 1.34 in parentheses squared. So that's all you had to do for that one. And then in number 30, a common formula, C equals 5/9 parentheses F minus 32 is what we're starting with, and we have to solve for F. So the first thing I did is I multiplied both sides of the equation by the reciprocal of the 5/9, which is 9/5, so that the 9/5 and the 5/9 will reduce, and I will then rewrite this as 9/5 C equals F minus 32, and then add your 32, and you'll have your F by itself. So then you get F equals 9/5 C plus 32. All right, so continuing now with problem 31, this is what we're starting with. Again, there was a typo there. Let me zoom in a little bit. So this is what we're starting with, the x plus 2 in parentheses to the 1/3 power minus 6. But if we're reflecting it over the x-axis, we have to take each of these terms. So this is basically one term, this is basically one term, and we're going to change the signs or distribute that -1 to both of those terms. So -1 parentheses x plus 2 to the 1/3 power plus 6 would give us the reflection over the x-axis. So that's the first step. Then it says followed by a translation 7 units to the right. So whenever you're doing a translation 7 units to the right, you're going to replace the x in your equation with x minus 7. So that will make the equation go to the right 7. Well, we've already got x here. So taking this equation, we don't necessarily need the 1 there, but I'm going to replace that x with x minus 7. So whether you put in parentheses or not by itself is not important, but this x gets replaced with x minus 7, but everything else is going to stay the same. Plus 2, and then to the 1/3 power, plus 6. So whenever you have a horizontal transformation of some sort, it's just the x that gets replaced with whatever you're doing with it. So the x gets changed to x minus 7. Now we can simplify what's inside. The -7 plus 2 is -5. You're still going to have the exponent of 1/3 plus 6. So your g of x function then is going to equal negative x minus 5 to the 1/3 power plus 6. Is that all we have to do? Yep. If we had to describe the domain, because it's an odd root, your domain would be all real numbers. But we don't have to do that here. All right. The next one, we have a square root function. And we're going to take this equation and I think I got my letters backwards again. All right, so I should have a g here. So let g be a translation of f 7 units up. So when you're when you're going 7 units up, you simply just have to add 7 to the k value. So if it's already up 2, then you just go up 7 more, and now you're up 9. So right now we just have x minus 1 plus 9. But then it says followed by a vertical compression by a factor of 1/3. So normally when we have a vertical stretch or vertical compression, we take whatever that number is times our f of x. So sort of like what you had to do when you were reflecting over the x-axis, you would take the -1 times the whole function. Well, with a vertical stretch or vertical compression, you're going to take that number times the whole function. So if there's more than one term in this function, you have to distribute the 1/3 to both of these things. Well, you can't multiply the 1/3 inside the radical. So when you distribute to the square root, just put the 1/3 in front, and then the 1/3 times 9 is going to be equal to 3. So there you have it. G of x equals 1/3 square root of x minus 1 plus 3. All right, so that is the end of chapter 4 review. Good luck studying, and good night.